Welcome to EDU World Space.
Okay, so we're doing chapter 32, problem 62. So in this problem, it shows a liquid detecting prism device. So what happens is we have this container that could or could not contain water. And connected to that, we have this right triangle prism. And then we have one light source coming in this way, straight on, and then it will then reflect out this way to a sensor. So we have a sensor here, we have a source here, and some of this might get refracted in. So the goal of this detector is when there is no liquid, then we want, so no liquid corresponds to total internal reflection. So that means the sensor is going to get the whole beam reflected and see the whole beam. So we have a large signal in the sensor with no liquid. So if there is water in there covering it, we want there to be some refraction into the water. So this means there's going to be a very small signal that gets reflected to the sensor. Okay, so now we want to figure out what's the minimum or what's the range of allowable index of refractions for the prism that give us this properties. Okay, so we can relate the critical angle as the second index over the first given here. So the light source is always going to enter at a 45-degree angle. If we look at this diagram up here, it's always going to be hitting the prism water or air interface at an angle, incident angle of 45 degrees. So we want that to be the critical angle for this. So if N1 is our prism, then our minimum in it can be gives our air interface a critical angle of 45 degrees. So this is 1 over sine of 45 degrees, and this gives us 1.41. Similarly, we can find the maximum N1 can be by looking at the water interface, because now we want the critical angle to be in water over sine theta c. So if we plug this in, we see that in water is 1.33 over sine of 45 degrees, and this comes out to be 1.88. So that's our minimum max. So N1 must be greater than 1.41, less than 1.88. Put less than or equal and greater than equal signs there. So that's the allowable range. So now it asks, will the device work properly if we make it out of inexpensive lucite? So it gives us the N for lucite to be 1.5, and that is in our range. So yes, it will work.